Hello, this video will give you a guidance of the sampling method and tips to collect water samples. This video is from the Elise Morrison Lab at the University of Florida. Today, we are going to measure water quality parameters using a handheld probe and collect samples for nutrients and total suspended solids. We will also show you how to collect particulate organic matter and dissolved organic matter. Lastly, we'll show you how to collect samples for the measurement of oxygen and hydrogen isotopes in water and for the measurement of oxygen isotopes in phosphate. We are collecting our water samples at Lake Alice on the University of Florida's campus. On the land, we can collect the water sample using a sampling pole or grab bottle, or you can use a bucket with rope to collect water samples from a structure. On a boat, we can also use a sampling pole or peristaltic pump. Rinse the bucket at least 3 times before collecting your water sample. Using those tools, water samples will be collected into one large bucket of water. 4 liters of water are plenty for all parameters shown here, with the exception of samples for phosphate oxygen isotopes, which require larger volumes of water. Also, we can attach to the tubing with a sampling pole. We can collect and filter the water directly from the water body into the sample bottle. This is the preferred method if you are collecting large volumes of water. We need a field notebook to write down all the information we got from the field. It's easy if you have a pre-made table for all the information you expect to collect. First, we measure the water monitoring parameters using a YSI sensor. Take a cup or a bottle of water for the sensor from the bucket. Please make sure that you rinse the bottle at least 3 times before use. Then, fill the bottle with sampling water. The sensor should be submerged in the collected water. Once the sensor data is stabilized, push the record button on the YSI sensor to save your data. Here, we are measuring dissolved oxygen, pH, conductivity, temperature, salinity, oxidation reduction potential, or ORP, and chlorophyll. However, if you do not have a probe with all of these sensors, the most important parameters to measure for our purposes are temperature, salinity, conductivity, and pH. For analyzing the phosphate-oxygen isotope ratio, it is very important that we record the temperature of the water. Also write down the time and the other parameters on the field note. After using the sensor, please make sure that you rinse the sensor with deionized water and place it back in its housing. Next, we will collect our water samples for nutrients. Triple rinse your bottle prior to sample collection, then collect the water in the Nalgene bottle. This method depends on the requirements of your analytical lab protocols. For the total suspended solids, total organic carbon, and total phosphorus, they are collected without filtration and acidification. Place collected water on the ice to keep at 4 degrees Celsius until they are delivered to the analytical lab. Now we are going to collect the filters for particulate organic matter, or POM samples. We use 70% ethanol to clean the forceps between samples. We pre-combust and pre-weigh our filters and then give each filter a unique ID, which is written on its foil envelope. It's very important to record the ID number as well as the sampling site ID in your field notebook. Take one 25mm glass fiber filter from a foil envelope using clean forceps and put it into the filter housing. The filter can be placed on the flat portion of the filter housing, but if it is windy, it can be easier to place the filter in the cap of the filter housing. Make sure the filter is centered, then close the filter housing. Remove the plunger and replace the housing. Rinse your syringe, then take 50 milliliters of water from the bucket into the syringe. and slowly push the plunger. Since we are going to collect POM, the filtrate can be discarded in this step. Using a total volume of 100 to 200 milliliters of water is recommended for POM, depending on how much particulate material you have in your sample. To filter more water, detach the housing from the syringe, remove the plunger, replace the housing, fill with water, and slowly push the plunger. Repeat the process 2 to 4 times. Write down the total filtered volume and filter number in your field notes. If the filter is too clogged by particles, it can become difficult to pass all the water through the filter. If this happens, you can check how much volume has been filtered and then disconnect the housing and throw away the remaining water. Then, push the plunger with the air to remove all moisture on the filter. In all cases, you will want to record the volume of water that has passed through the filter, as well as the unique filter ID that is located on the foil envelope. After all filtration, use the clean forceps. Carefully remove the filter from the housing and place it into the aluminum foil. The easiest way to fold the filter is to place the filter over an existing crease in the foil. Use the forceps to place the filter on the crease, being sure to only touch the white edges of the filter to avoid removing any particulate material from the filter. Check that the edges of the filter are aligned, and then use the foil to fold the filter in half, then close the envelope. As mentioned before, be sure to record the name of the site and the unique filter ID in your field notebook. Put it in the labeled Ziploc and place the bag in a cooler. Multiple filters can go in the same bag, just be sure to close each foil envelope well. Sometimes we need to collect dissolved organic matter, which can include dissolved organic carbon and colored dissolved organic matter, or CDOM, in addition to nutrients. This is how we collect DOC and CDOM. We use pre-combusted glass vials which have been baked at 450 degrees Celsius for at least 4 hours. Here, we are filtering the DOC and CDOM samples with a 0.2 micrometer filter, using the syringe filtration approach described earlier. When filtering, first flush the filter with slight water and discard, then begin to filter directly into the sampling vial. For a DOC sample, add a few drops of 6 molar hydrochloric acid to get a pH of approximately 2. After shaking well, check the pH with pH strips to make sure that the pH is below 2. Ensure that you do not place the pH strip directly into the sample vial, but instead pour the sample over the pH strip, or place a small amount of sample in the cap and measure the pH and discard. This acid will prevent biological activity and help to remove all dissolved inorganic carbon before measuring DOC. Also, store the collected water sample in the cooler. It is critical to store CDOM samples in amber vials to prevent photodegradation and below 4 degrees Celsius. They need to be measured as soon as possible after collection. Next, we are going to collect the sample to measure the stable isotope ratios of oxygen and hydrogen in water. Unfiltered water samples are collected for this analysis, and samples are kept at 4 degrees Celsius until analysis. Pour the untreated water into this 2 milliliter vial until the vial is completely full. Sometimes small bubbles can get stuck in the vial, so inspect the vial to ensure that there are no bubbles. And if there are bubbles, tap the vial and then continue to fill it to the brim. Close the cap and place these vials into their storage box and then in a cooler. To collect the sample to measure the phosphate-oxygen isotope ratio, we need a large volume of water. The exact amount needed depends on the orthophosphate concentration in your water sample. If the water contains 0.05 milligrams per liter of phosphate, then we need to collect around 30 liters of water. To collect bulk filtered water, we use a 0.2 micrometer cartridge filter. Put the cartridge filter into the filter housing and close tightly to prevent leaking. Then, connect the tubing to the peristaltic pump. You can use a rechargeable peristaltic pump or just a peristaltic pump with a car battery. If you use this type of peristaltic pump, connect the pump to the battery. Switch on the pump and collect the water into the large bottle or carboy. Please make sure that you rinse your bottle at least 3 times prior to sample collection. Depending on the volume needed and the volume of your bottles, you may need to collect multiple bottles. Filtered water samples need to be chilled on ice after collection and stored at 4 degrees Celsius before processing within a week. 27-gallon large heavy-duty boxes are useful to store 2 5-gallon carboys with ice during the sampling. If you have any questions about these sampling methods, you can reach out to our lab. Thank you for watching.